Hello everyone. My name is Mittal Domadiya and today I will talk about chiplet architecture. I am really excited to talk about the chiplet architecture. This is a new and advanced way of designing a semiconductors. Instead of building one giant chip, we use multiple smaller chips called chiplets and put them together in a single package. So why do we do this? Well, making one big chip is becoming more difficult and expensive because of increasing design complexity. So in the further slides, we will discuss about chiplet architecture and how they solves our problem. Alright, let's understand why chiplet architecture is becoming important. Traditional chip design used to work well when chips were simpler. But as our demand grew, we need more powerful and complex chips. Making everything work on a single large chips has becoming almost impossible due to cost and manufacturing limitations. For example, think about how phones and laptops keep getting faster and better. To keep up, engineers need a new approach, and that's where chiplets comes. They allows for breaking the design into a smaller and easier to manage parts. Plus, using chiplet can help reduce cost significantly and make upgrade much easier. Now, comparing traditional and chiplet based design in a interesting way. So imagine trying to put all your tech requirement into a one big heavy backup. It's difficult to carry and manage, right? That's what a traditional chip is like. One giant complicated design. On the other hand, using chiplet is like dividing your load into a smaller organized bag. It's easier to carry and most efficient. While chiplet engineer can pick and choose different technology for a different parts. For instance, one chiplet might be dedicated to memory while another handles processing tasks. This way, we get a balanced and optimized system. Now, how does this architecture actually work? Let's think of it as a building a house. Instead of making a single complicated structure, you might individual room and connect them. Each room has a specific purpose, like a kitchen or a bathroom. Similarly, chiplets are designed to handle specific tasks like data processing or storage. These chiplets are then connected using advanced interconnections that allows them to communicate efficiently. Technology like high-speed data buses or a specific connectors make sure the chiplet work together as a single unit. By doing this, we can combine different technology in a one package, making the system more versatile. Advantages of chiplet architectures. There are quite a few advantages to this approach. The first is cost reductions. Since chiplets are smaller, they are easier and cheaper to produce. This is a big win for a companies trying to keep expenses low. The second advantage is performance. By using the best technology for each chiplet, we can get better overall performance. For example, if one part of the chip need to be super fast, we can use cutting edge technology just for that part. Laterally, flexibility and scalability are the key points. If we need to make a chip more powerful, we can just add or swap our chiplet without having to redesign the whole thing. This saves time and resources. So let's discuss about challenges of chiplet architecture. Of course, nothing is perfect. Chiplet architecture has its own sets of challenges. One major issue is making such that chiplet communication is efficiently. If the connections between them are slower or unreliable, the whole system suffers. This is called latency, and it can be a big problem. Another challenge is heat management. Since chiplets are packed closer together, they can generate a lot of heat. Engineers are working on advanced cooling solutions to handle this, like using a special material or improving airflow design. So, while chiplet architecture is promising, it does require careful planning and innovations. So let's discuss about applications and industry adaptations. Chiplet architecture is not just a theory. It's already being used in the industries. A greater example is AMD. Their EPYC processors used in the data centers rely on the chiplets. By using this design, AMD has managed to improve performance significantly and reduced cost at the same time. Other companies, especially in the field of AI or artificial intelligence and high performing computer, are also exploring this architecture. So the question arises, why? Because it provides a way to keep up with the demand for a faster and a more efficient technology without breaking the bank. So let's discuss about future of chiplet architecture. Looking into the future, chiplet architecture has a lot of exciting possibilities. Researchers are working on a new material like graphene. These material promise faster electronic movement and lower power usage, which could make chiplets even more efficient. There are also a lot of work being done on a 3D packaging. This means stacking chiplets on a top of each other to save space and improve performance. It's like building a skyscraper instead of spreading out a bunch of houses. And then there's a photonic interconnections, which use light instead of electricity for data transfer. This could make communication between chiplets much faster and more efficient. So let's discuss the potential breakthrough. Here, dive a bit deeper into some future breakthroughs. For example, advanced material research is exploring how new substance can make chiplet faster and less power hungry. Graphene, for instance, has extremely high electronic mobility, which could revolutionize how data move within a chiplet. 3D stacking is another game changer. It allows for more compact design, but it also brings challenges like heat emissions. Engineers are trying to solve this with innovative cooling solutions, and photonic interconnection are really exciting areas. Imagine data moving at the speed of light with almost no power loss. It's still in development. Now let's discuss about industry adaptations. Chiplet architecture is not just for a tech giant like AMD. Other industries, including those working on AI and machine learning, are starting to adopt this design. The flexibility it offers is very appealing because it allows companies to tailor make their chip for a specific applications. As technology evolves, we can expect even more wider space of this use of the use. Now let's discuss about AMD EPYC processors. So let's take a closer look at the AMD EPYC processors. This is a perfect example of how chiplet architecture is being used successfully. By separating different functions into various chiplets, AMD was able to create a powerful yet cost-efficient processor for a data center. This design has made a big impact, improving performance while keeping the cost down. It's a clear demonstration of why more companies are interested in this architecture. So last is conclusion. In conclusion, chiplet architecture represents a major shift in semiconductor design. It offers a way to make chips cheaper and more efficient and easy to upgrade. While there are challenges like communication and heat management, the potential benefit make it worth pursuing. So thank you for your attention, and I hope this presentation gave you a good understanding of a chiplet architecture. Thank you.